The effects of sexual selection on titillators in bush crickets. It was believed that selective pressure had caused the diversification of the genitals of animals. This is a result of evolution, which is the change in genotype frequencies resulting in new or different phenotypes. Sexual selection, where mates are chosen non-randomly because of the traits they possess, is a mechanism of evolution, which can alter the way a species behaves when mating, and scientists were curious as to how this affected bush crickets specifically. The key question that scientists wanted to analyze was, does the complexity and presence of titillators affect such behaviors in bush crickets? Titillators are chitinized structures that are used in copulation by bush crickets. Before testing, scientists analyzed two different types of data. To start, they gathered data on the average polyandry of 29 different species of bush crickets. Polyandry is the number of times one member of a species mates with different members of the same species. The way this data was analyzed was by counting the number of spermatodoses, which are capsules of sperm in the female sperm organ that form each time they mate. Inside a female cricket, the spermatodoses can be used to see how many times the cricket had mated. The number of spermatodoses found can be used to estimate the refractory period of the cricket due to the relationship between shorter refractory periods and more repetitive mating. The second set of data that scientists retrieved was morphological data. This data was the different titillator complexities. The classification of each type of titillator was ranked based on complexity, with 0 being not having a titillator at all, and 6 being the most complex titillator. To analyze the effects of titillators, scientists analyzed two different categories, the first being the presence of titillators, and the second being the complexity of the titillators. The data for repetitive mating ended up showing that polyandry was neither related to titillator complexity nor to titillator presence. The data did, however, show a trend that the male crickets with more complex titillators had longer refractory periods, but the data did not show that the actual presence of titillators affected the male refractory period. Female refractory period, on the other hand, increased in the presence of titillators, but it decreased as the titillators became more complex. The results show that the titillators do not affect the likelihood that bush crickets attract a mate, and that their evolution is not a result of the crickets being more likely to attract a mate. If this was the case, directional selection would have shifted the gene curve towards the more complex titillators because those crickets would have been more likely to gain a mate. In fact, it can be said that natural selection is working against males and for females because of the graphical trends. It reduces the individual fitness of the males because they are not allowed to mate as much, while increasing the individual fitness of the females because they are allowed to mate more frequently because of their refractory period trends.